Hello students, today we are going to study model laws. For dynamic similarity between model and prototype, ratio of dimensionless number, that is the Reynolds number, Froude number, Euler's number, Weber's number, mesh number should be same for model and prototype. But it is difficult to satisfy all the forces ratios. Hence, models are designed on the basis of ratio of forces which are dominating in the phenomena. Thus, we have various model laws depending on the forces which are dominant in the flow. Now, the first one is Reynolds Model Law. The situation where, apart from inertial force, only viscous forces are dominant, Reynolds Model Law is used. That is, Reynolds number of model should be equals to Reynolds number of prototype, that is shown here. So it will be equals to rho of model into V of model into L of model upon mu of model will be equals to rho of prototype into V of prototype into L of prototype upon mu of prototype. The ratio of rho r, Vr, Lr upon mu r will be equals to 1, which is shown here. Now next topic is the Reynolds model law is used in for pipe flow where viscosity has significant effect like laminar flow. Next one is flow around completely submerged objects like submarines, airplanes, automobiles, etc. Parachutes when there is drag, that is when not falling in vacuum. Thus, in this law, Vr will be equals to mu r upon rho r into Lr, which is the velocity ratio. Next one is the Tr equals to Lr upon Vr, which will be equals to rho r into Lr square upon mu r, that is the time ratio. Now, Ar will be equals to Vr upon Tr, which will be equals to mu r square upon rho r square into Lr cube, which will be equals to acceleration ratio. Now, Fr will be equals to Mr into Ar, which will be equals to mu r square upon rho r, that is the force ratio. Next one will be the Pr equals to Fr into Vr, which will be equals to mu r cube upon rho r square into Lr, which will be equals to power ratio. And Qr will be equals to Lr cube upon Tr, which will be equals to mu r into Lr upon rho r, which is known as discharge ratio. Now one note is written here, if mu and rho are same, then rho r into Lr into Vr upon mu r will be equals to 1, therefore Lr into Vr will be equals to 1. Now next will be the Froude's model law. The law is applicable when in addition to inertia force, gravity forces are important. That is shown here. Now, Vr upon under root of Gr into Lr will be equals to 1. If model and prototype are at same location, that is, if G is constant, then Vr upon under root of Lr will be equals to 1, where L equals to length parameter. Now, L will be equals to hydraulic depth, which will be equals to A by P in case of open channel, that is wetted area upon wetted parameter. Now, Froude's model law is used in free surface flow such as flow over spillway, weirs, channels, hydraulic jumps, etc. Flow of liquid jet from orifice, flow over weir and notches, motion of ship in rough and turbulent sea. Now in this case, Vr will be equals to under root of Lr, that is the velocity ratio, and Tr will be equals to Lr upon Vr, which will be equals to under root of Lr, that is the time ratio. Now next one will be the Ar, which will be equals to Vr upon Tr, that will be equals to under root of Lr upon under root of Lr will be equals to 1, that is the acceleration ratio. Now next one will be the Fr will be equals to Mr into Ar, which will be equals to rho r into Lr cube equals to force ratio. Now Pr will be equals to rho r into Lr to the power 7 by 2, which will be known as power ratio, and Qr will be equals to Lr to the power 2.5, which will be known as discharge ratio. Now next one will be the Euler's Model Law. When apart from inertia forces, only pressure forces is dominant, this law is applicable. In this case, Euler's number of model will be equals to Euler's number of prototype. Therefore, VR upon under root of PR upon rho r will be equals to 1. Now, Euler's model law is used in case of pipe flow at high pressure, in case of cavitation, and for pressure due to sudden closure of valve. Now, next one will be the Weber's model law. When apart from inertia forces, surface tension forces is dominant, then Weber's number for model will be equals to Weber's number for prototype. Therefore, VR upon under root of sigma r upon rho r into Lr will be equals to 1. Weber's model law is used in capillary rise in narrow passages, flow over weirs for small heads, rising bubble, seepage flow through soil, flow of blood in veins and arteries. Now next is the mesh model law. When apart from inertia forces, compressibility forces is dominant, we use mesh law. Now compressibility forces are predominant when mesh number is greater than equals to 0.3. That is, speed of movement will be greater than equals to 0.3 into velocity of sound. When mesh number is less than 1, it is called as subsonic. When mesh number is greater than 1, it is called as supersonic, and when mesh number equals to 1, it is called sonic. When mesh number is 2 greater than 1, it is called hypersonic. When mesh number is less than 0.3, it is called compressibility effect and can be neglected. In this case, mesh number of model will be equals to mesh number of prototype. Therefore, VR upon under root of KR upon rho r will be equals to 1. Now, mesh model law is used in aerodynamic testing such as launching of missiles, rockets, etc., underwater testing of torpedoes, water hammer pressure, and the last one is flow of gases through pipe at high velocity. That is all about the model laws. Thank you very much, students.